Hello.
Hey, give me a minute.
Yeah, uh, I can hear you. You can hear me, right?
Oh yeah, I can hear you. Yeah,
Yeah. My name is Piyush.
yeah, I'm Alex.
Yeah. Hi. Seems like I'm first. So let me just read the question.
Sure, go ahead.
So next tree is which can be constructed by starting the line segment of arbitrary length, drawing two segments of the same length and continuing with the same vein. Depth 1. Write a function draw a tree that constructs an tree given x and y coordinate, a starting length and depth. Assume that the starting line is parallel to y-axis. Use the function draw line.
So yeah,
Function render a real line. However, so okay. So according to this particular question, I will be given one x and one y, which will be the coordinates, and then
yes.
the length of the line, and basically I have, and there will be a depth, and I have to uh, draw it, right?
You don't have to draw it. So basically, this function here is just it's given. So we assume that this is. Uh, so you don't have to implement this, but you do have to implement draw h tree, given that draw line is already implemented.
Yeah. Okay. Okay. So here for depth one, it's only h. For depth two, at every corner, I have to create an edge, right? And for depth three, again for every corner, I have to create an edge. Okay. And write a function draw line. Print format is the left to the discretion. Draw a string. Okay, so I'm thinking some kind of recursive function. So basically, for depth one, I already know the answer, right? And for greater depths, what I can do is I can check out the coordinates by taking length and x and y into account, and produce those coordinates to attach another edge to this particular edge. And this will go on recursively for whatever um, depth you want. So basically, what I can do is I can do breadth first something kind of solution where I keep on pushing the coordinates. Um, so it will be basically like a tree, right? So the root is h, and then whenever you so you push all the corners into a cube, and as soon as your depth is 2, you pop out all the corners and then fix h um, on each corners, and then push again the corners of that particular edge. so that once you have everything, then for at any depth you can go and you need to run the loop for that many depth, and all the coordinates in the queue should be like a whole kind of edge. um,
So let's roll back a little bit. So you said you mentioned about recursion. Can you explain how you're gonna use
yeah,
recursion?
so actually I am deterring from the recursive solution. So what I'm trying to do is, um, so I am doing some kind of breadth first solution, right? So I will have a queue, um, which will have so for 0, like it will return empty, right? If the depth is 0, it will return empty. For depth 1, I already know the solution. So x and y and all, so I can figure out the solution for 1. So I will create a queue, right? And for depth 1, I can push all the corner coordinate of h into the queue, right? And so this will be in the loop for I in 0 to depth, whatever depth we want to go. So for each level I will pop out all the corners and create one more edge for that particular x and y, because length is constant for every time, right? So I will create one more edge and I will push all the corners in that queue again. Okay.
Okay,
So
so you're not using recursion. You're rather
yeah,
using a queue.
yeah, yeah.
You probably gonna use some while loop, which I assume what you mean by BFS solution. So in here you have to notice that the size is shrinking,
Yeah.
um, and you have to stop at a certain depth. So how are you going to handle those
So
situations?
I'm running a loop for the depth, right? So the number of times I have to pop out all the corners is the number of depth I want to go. So whenever I'm pushing, I will be having some variable that will be containing the depth at which I am right now. So for each coordinate, I can have a variable called depth. So for the first edge, when I will input the variables like x, y, and length, I can have one depth variable also. So the corners which I will push, it will be like 1, right? And whenever I am going above the depth, I will not push it into the queue. So that's how I will control the depth portion of it. For the length, let me actually read the question again. So how are we shrinking the length? Okay, so the lines at every stage it is like a square root, right? Um, and continuing the same way, dividing the length of the line segment drawn at each stage by half. No, so dividing it by square root. So for every length, for every iteration, I will have like L divided by square root. So that will take care of the length variable.
So is there, so I understand how you're trying to solve it. Is there a particular reason why you chose BFS?
It will be easier to implement. I think that's it. For recursive solution also, like you can have it as, so you need to maintain the depth and length of every coordinate, and then you have to call that particular function for every x and y, right? And uh, I think like that can also be done. So it's like a more like a counterpart, but actually, breadth first is more kind of intuitive to me for coding it down. So that's why I chose it. But it can be done with recursive also. Uh, so the logic will be same, right? So you need to call the recursive function for every x and y, like for all the corners of h, you need to call one recursive function for that, but the thing will be like length will be divided by root 2 for each of them.
So
And
you're choosing BFS because it's easier to implement for you.
Yeah.
Is it okay? Let's go to coding.
Okay. 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 So let's try to figure out the coordinates first, right? So x, y. This is my middle coordinate, and I'm assuming like the middle means this one, right? From h, if I'm at h, so the middle line middle coordinate. That is what x, y is depicting here, right?
Yeah, yeah.
So so can I assume like it will be like 45-degree angle with every corner?
It won't be 45-degree angle. It'll be 90 degrees angle um, for all the intersects. They're perpendicular lines.
So what is xy here? So is it like one particular corner, or is it in between this h line?
The xy is the center coordinate.
Yes. So so for example, um, right. So this is s. So xy is here, right, where my cursor is.
Yes.
So if I have to take the corner of the top here, so it will be something 45-degree, right?
45-degree
If I
is
draw a
not.
line, uh, horizontal to that particular corner.
Oh, so you're saying the horizontal to the corner.
Yeah.
Well,
Like diagonal to corner. Sorry, not horizontal. Yeah.
I'm just gonna say that you don't need to focus on 45 degrees,
Okay.
um, just to stop you from going to a rabbit hole. All you need to do is to draw three lines, right? Each has a three lines,
Yeah.
and you have a center coordinate, and you can draw the horizontal line based on center coordinate and the length, and you can draw the other two, uh, and they are the same length. So
Correct.
the horizontal is the same length as a
So it will
bar.
be just like negative and positive. That's it. Like for above and below, it's like mirror image, right?
Yeah, and yeah, feel free to define how that x goes 0 to 1 in which direction. Um,
Yeah. So considering like my length, right? So the length is given. So my right side would be like x plus length by 2, right? And my left left side would be x minus l by 2, and my y coordinate would be um, so it will be like y minus l by 2, sorry, y plus l by 2, and it will be again y 1 plus l by 2, and then my third and fourth would be so these things will be same, l by 2 and y 1 minus l by 2, and the fourth one will be this thing, right? So these are all my four coordinates up and down.
yep.
Okay. So now here I am getting x and y. So I can define a q, and it will take some kind of variables, right? So x, y, length, if I can spell it correctly, sorry. And the depth is 0. So this is my root node. Now, um, while q. So I will be popping out, and what I can do is, uh, let's say underscore x, underscore y, underscore length, and the underscore depth, right? So this all will be taken out from here. Q dot pop, and then I can check. Sorry about the spelling. I can check if depth is less than, sorry, underscore depth. If underscore depth is less than depth, less than equal to depth, right? So what I can do is I can have these 4 coordinates. So I can uh, q. Actually, before this, I need to draw line, uh, underscore x, comma underscore. Okay, so the draw line is taking um the coordinates, right? Okay, so I have to call this draw line 4 times just to make a complete edge.
So there are 3 lines per
Yeah,
page.
yeah. Um, I can write a function, right? So def create an edge, which will take x and y and the length, and it will give me an edge. So it will use the draw line feature. So so I will draw line, or I don't need it because anyways I have to put it into the queue. So let me just make the x1 y1 is equal to um, x underscore x plus underscore length uh, by 2. So I'm assuming that I'm doing the integer division here. So do you want me to have a floating point, or integer is fine?
Let's just say that, yeah, it's a power of 2. All the lengths are power of 2.
Okay. So underscore y plus underscore length divided by 2, right? And let me just copy it. So it will be like x2 y2, and it will be x this, and it will be same, then x3 y3, and it will be underscore x plus this, and this will be minus, and here also this will be minus, and this will be like x4, and this will be x4. So now I have got all the coordinates here. Now I have to draw line. So I will first draw a line in between x1 comma x2 comma x3, sorry, y2, x3 and y3, and then I will draw a line between x2, y2, and x4 y4. So this will be like my both vertical lines, and then I have to draw a line in between, right? So draw a line, and for this it will be like x underscore x um, underscore x comma underscore y comma comma underscore y, right? So the y will be constant here, but my x will vary by uh, length by 2. So this will give me the first two will give me the vertical lines, and the third one will give me the horizontal line to create an edge, right? And then what I need to do is I need to enter this into the queue. So it will be something like x1 comma y1 comma um, length will be underscore length will be divided by square root of 2. So I think it's 1.41, right? I'm just assuming a floating point here. Is that fine? Or
That's fine.
and then the depth will be increased by 1, and this I have to do for all the coordinates. Hmm. So x2 y2 x3 y3 x4 y4, and the length and depth will be same for each and every of them. And here I am checking for the depth itself. So that so this will make sure like I am not entering the +1 level also. And yeah, I think that should work. So at the end, like my queue will be empty and I will be exiting from here, and I don't have to return anything, right? So it will be drawn. Yeah, I
So let's run through an example.
okay.
Let's just say OH3 002. Let's start with depth 0.
Okay,
So what would that come out to be?
so my xy is 0 0. um let's assume the length is 16 for now, and
Sure.
depth, let's take it to 2 level or 3 level,
Let's take it to 0 and see what happens.
for 0 itself, right? Okay. So my queue will be in the beginning. It will be queue will be having 0 comma 0 comma 16 comma 0, and here I will pop it, right. So my underscore x will be 0, underscore y will be 0, underscore length will be 16, and underscore depth will be 0, right. So now um, for this I will calculate my x1. x1 will be minus x, sorry, 0 plus 8. So 8, then and y1 will be um,
Well, before we do any calculation there, so that depth is 0, so it's not supposed to draw anything.
oh, sorry, I thought like depth 0 is like single edge. So sorry, that's uh, my that was my error. So depth.
And so now that you know, how would you change the function?
Sorry.
Now you know that. How would you change the function? Oh, if not depth. So let's go with 1 then. What do you think is going to happen?
Okay.
Let's not do all the because we only have 3 minutes.
Okay.
Do you think this will work with 1? Oh, you added a +1 there too.
Yeah, yeah,
Okay.
yeah. That I'm checking.
Sure. So 1 0 1 1 1 2. All right. Yeah, that'll work. Great. Sounds good.
Okay. So let's switch the role then. I think it's there is no test case for that. So, yeah.
Cool. So given two Sawyer machines. So the question is that I'm given two arrays and then they have integers inside them, and I'm supposed to find which one has the um, which number has is in both R1 and R2. Is that correct?
Yes, that's correct.
In both the R1 and R2, at least have a one element up to 100, and the output is the array of integers. So what if there is no duplicates? Do I return empty?
Yeah,
Empty list.
yeah. Because it's
Cool.
an array, right? So
Mhm. So one easy way that I can think of right at the bat is to use a set. So if I convert R1 as a set and R2 as a set, find an intersect, I can compute the output. So will this catch the cases where there's multiple same numbers? So what I'm but these are not all unique values, if I'm correct. So it could be as far as that. In this case, the answer output, I'm guessing, is supposed to be this. Is that correct?
yes,
Okay, so in that case, it would not, using a set will not work because a set would just reduce all that three ones into one ones.
correct.
Um, Another one is I use a two-point approach where I start from index 0 for R1 and R2,
Mhm.
and then I increment each one up. And because there's a difference between the values, how I choose to increment the pointer would be I'll increment the one that is lower because that would always ensure that I don't overskip a larger value. So in this case, for and it's a case like this, um, I would start at here, and then I would start at here, and they're the same. So I'm going to append to the output. And since they are the same, both of them has to increment. Um, and they're not the same, the lower value would increment.
Hmm.
If they're the same, both would increment, and they will continue to go until one of them runs out, or when the pointer is greater than the length of the array that is pointing to.
Hmm.
That would catch if there's a duplicate. For instance, if there's another one here, it would advance together. So um, it would append one, and then it will move together. It would append another one, and it will move together, and this would uh, create. Uh, yeah, this will create the output array.
Yeah, sounds good.
Uh,
One follow-up question. So, suppose your array 2 is very large, right? So it's in the order of 10 to the power 9, and your array 1 is relatively small, for example, 100 or 200. So, can we optimize this approach to have a better time complexity there?
okay, so let me try to think of what the complexity is for here. So this is a min between the length of array 1 and length of array 2. Um, the space here would be just the output itself, which would be whatever it's a max between. This is also a min between R1, length of R1, and length of R2. Um, in terms of in terms of
So,
the
this time and space complexity, like for which use case are you telling? Like which approach you are telling for this
oh
one?
I, yeah, I'm still yeah looking at this one. So
Uh,
we're
so, can you
trying to
explain me
do
like how the time complexity is minimum of length of array 1 and array 2?
so in a worst case, all of them are uniquely different, and um, so okay, so I'm stating that in the time complexity that the min time will be 4, because the length of the array 1 is the minimum length, and then it's 4, which obviously is not. Um, so it's actually the max.
Yes.
Um, and for same for there could be uh, essentially a same value.
So, in the space or space complexity, which space are you counting here? Like what all spaces are you counting here?
I'm counting the output as well. If we don't
Oh,
count the
yeah.
output, then
Okay.
it will be constant space, just the pointers. Um, so if I want to do better than this, uh,
So if you're counting the output, so then it will be minimum of space, right? At max, you can match the smallest number of character, like the array.
so here, if I have 3 of these, then it will be 3. So in a worst case scenario. So we're not speaking about the worst case. It could be up to the max of length because this will create this value. Uh,
The worst case will be the min of length, right? The length can be equal, then like it is always equal to min, right?
I can argue that well, I can argue that why it's max because in this case already, if I say max, the worst case is max of these two values. Uh,
No, it is the min of these two values. So in this case, it was like same.
oh yeah, of course, yeah, I get, yeah. So the idea is that the duplicates cannot be longer than the shortest array itself.
Sure. Yeah.
Okay, so if I want to do better than this, so so we're suggesting here that there's a really long array here, and then there is here 3 and 5. Um, so, or possibly uh, 9 and 10.
Hmm.
So we don't need to look through all of them, um, but we can figure this out. Since this is ascending order, there is a neat trick of a binary search to make this more efficient.
Hmm.
So doing a binary search on the longer array would be um, 12, 2 length of R1 times R length of R2. So not necessarily this will be faster. If we have a same R length of R1 and R2, it would run slower than the first example. But yeah, on the case that we have this large discrepancy between size, this would be faster.
Yeah.
And space is same uh, as above. So, do you want me to go and code this?
Yeah. So let's code the binary search one.
Sure. So I'm gonna first check, and I'm coding the binary search wrong. So if the length of R1 is, let's just say that length of R would be always greater. So if it's less than length of R2, we're just going to return the value that we found from swapping them. So we ensure that the first array always has a longer array. And the other one is that I need to implement a binary search,
Hmm.
which I would like to do it in a separate function, since binary search is a very common algorithm, or it has a many use cases in different places. So there's an R, and then we have in this case, we just need a start or a value that we're trying to find. Normally, we would, if I want to be modular and if I want to reuse the code, it would be a start and, but in this case, at least has a no value for it. So I'm just going to put a default value and then and there's a length of R -1. Um, and I will implement this very shortly after I finish the structure of find duplicates. So what I need to do is to iterate through the R2 for a value in R2. So here I'll be finding the duplicates. So here I need to decide whether binary search is going to return a boolean or some number. In this case, I'm choosing it to return boolean. And yeah, but in other cases, it might be useful to make it as a return index value. Um, so if binary search on R1 of the value, then I would append to the result. Um, and then this will be the value, and the result will start as an empty array. And after that, going through that, I'll be returning the results. So I am going through the array 2, and for each value, I'm trying to find by binary search on the R1 if the value exists. So here, the binary search is just a standard algorithm. There's a recursive way and iterative way to do it. I'm choosing to do it iteratively just because it doesn't incur that extra space that recursion tree incurs. Um, so start and end. Um, so while start is less than end, so equal to end. The mid is start plus n divided by 2. And if our mid is equal to the value that we're trying to reach, then return true. Um, and if it's smaller than the value, then we would need to um, move the start up. Else, if it's greater than the value, then we need to reduce the end. And if there is no value, then return um, false. So in this case, it would append the result. You mind if I go through an example?
Sure.
All right, so I'm going to
Um, so let's
use.
take this example. I think, yeah. Uh,
All right, so it's 1 and 10. So uh, I'm
just give me a second. So yeah, let's go through this.
oh, in this case, actually, this wouldn't work. Um, just because that if there's a so trying to find the binary search itself is not enough. It has to include an index. So what I need to do is to find leftmost in leftmost uh, value um, in the array. All right, so I'm going to modify this a bit. So this is not just a binary search. This is a leftmost binary search, and now the start has to be passed on. Um, so let's see. Um, so I delete this. So what I'm trying to do now is to find the leftmost value and the start from the index from the start to the end. And I can't just return true and false just because I need to return what the index that was found. Um, so what this will do is it's going to return a number. And if it doesn't have a value, I have to return -1. And -1 means that there is no value in there. So I check for that. Um, I do need to store this value. So I do need to move stuff around a little bit. Um, so index, binary search, index. And I do have to keep the leftmost index so far. And this will be -1. Um, and the binary search will have stuff in 0, obviously. Um, so far. So in that case, it would continue to move the start to the right. Um, and if it's -1, I update the left index so far into the new index and append to the result of the value. So this would catch on the case where there's more than uh, the number of duplicates.
I didn't understood this leftmost index so far. What it is trying to do here?
It's going to carry what the index that I have reached so far. So I can demonstrate in this example.
Oh, I got it. So if you got the leftmost one, then you'll start from like the ahead, right? Start +1 next
Yeah,
time if you do the binary search.
exactly. And it will continue to move to the right because both of them are ascending. So
Okay.
what I need to implement here is binary search leftmost,
So,
um,
okay.
which I believe
Think
uh,
there is an error, but yeah, let's see. Yeah, uh, let's proceed.
Yeah, so let's see. I think so. If I want to get the leftmost, I want to continue to move to the left until um, either there is no more index or um, all right, let's think about this. All right, so in this case, I would start at 2, and then I would move it 1, and I will move it 1 again. So I'm essentially traveling until it's no longer the number, the value that I'm looking for. Huh. So how do I describe this? So while start is, this will be obviously the same, but I have to check um, submit value would be the same as well. What I do have to check is that if and how do I describe this? If the mid is 0 or uh, our mid minus 1 is, or it's not the value, then this is where we know that it has the leftmost value. So, but if it's not, I would need to move the pointers. Um, so this will be, if it's or it's less than the value that we're trying to look for, then the mid would be, so I believe this would work. So I'm essentially moving to the left. So there is one thing that I'm, if the mid is smaller. So if the mid is the same value, but it doesn't fit this category, it will continue to move to the left. So, or it's, the mid is, the center value is less than value and needs to go, if the mid, if the center value is less than, let's say 5, then the start needs to go. So yeah, there's, and it would, this would continue to move it to the left.
Okay.
All right, so I think this will work.
Yeah. Uh, yeah. So, so are you done with the code, or you have to do something else? Okay, so let's do a dry run. So I can see a bug, but let's see like if you can catch it. So let's take my example itself, right? The second one, the one that I've given you.
All right, so let's walk through this. So I'm on line 42, and let's just say LM is 0.
Mhm.
And I'm on this value, so let this caret be the LM. um, and it's going to find that one. Assuming that the find and leftmost search does its job, that it's going to find this value, and
Yeah.
then it's going to, oh yeah, it's going to have to um,
Yeah.
do a plus one and move it, and the next one will be this, and then it will find this value, and then it will move it, and this there is none, so move it, then there's none. So yeah,
Yeah. I think now it's correct. Um, yeah. Do you want to run it on the test case?
set
Array.
where
Uh, array boolean.
does I thought Python supported this, which I didn't. All right, so I do have to just. So
It's minus. Not
is it later version of Python that supports this? Right.
okay.
So binary search is not defined, of course. I
Yeah.
check.
Nice. So
Yeah, I needed some guidance, which is no bueno for me, but you know,
yeah, it's fine,
it's
man. You got to the right solution. So
well, not the job I'm applying for, but
okay. So you're
it's
trying to give like switch jobs, or you're a student right now?
yeah. I mean, I have a interviews coming up with like big techs or whatever. So yeah, I'm
Okay.
kind of coming back to the basics. Um,
Oh, nice. So you have work experience, or
no, just like 3 years.
oh, nice. Okay, cool. Yeah. So it was nice meeting you. See
Yeah,
you next time. Okay. Bye
yeah.
bye then.
Bye.